Okay, I think that it's a good amount of time to allow people to have arrived. Welcome, everyone. My name is Scott Collis, and we'll go through some introductions later. But welcome to the first in this series of Earth and Environmental System Science Division's Open House. We are kicking off this Open House series with atmospheric system research. I'm just going to advance my slide here. The aim of this series is to inform potential and existing stakeholders in the Earth Environmental System Science Division stakeholder community of opportunities in the divisions. We're focusing on ASR today. This meeting will be recorded, and I'm just going to repeat that by being here, you are okay with that. We will determine what we do with the recording at a later date, but the very minimum we shared with DOE and with the participants. You are muted on entry. Please stay muted until the question and answer session. At that time, we'll be using that raise hands method for asking questions, and you'll be able to unmute yourself. We are in a normal Zoom system here. This is not Zoom webinar, so it really depends on folks staying muted throughout. I'm going to start with the Office of Science's statement of conduct. Basically, just to put this in a nutshell, it's demonstrating respect and consideration for all people, communicating openly and thoughtfully with others, listening well to others, and being considerate of the multitude of views and opinions which are different to your own, being respectful in discussing and debating ideas, demonstrating there are differing perspectives that are valued, and most importantly, I don't think this will be an issue at all in this seminar, critiquing ideas and not people. And you can read the full statement of commitment down at the bottom here, or Google it. So an overview of what we're going to be doing today. We're going to start with a round of introductions for the DOE staff who are here. We're going to introduce the Department of Energy's Office of Science Biological and Environmental Research Program and ASR's role in it, to provide some context of where ASR and Environmental and Earth System Science Division sits within the Office of Science. We're going to introduce you to ASR and its portfolio of research. We're then going to give you some guidance and advice for you and the community of how to engage with ASR on a variety of levels. And the most exciting part at the end will be an open session of question and answer, with the questions coming from you, the community, for our DOE staff here. So with that said, we're going to proceed to introductions, and I'm going to hand it over to Shaima Nasri to introduce herself.
Hi, everyone. My name is, as Scott said, Shaima Nasri. I am one of the two program managers for ASR. I have been here at DOE since about 2014. I spent my first year here on detail as an IPA from Texas A&M University. And then became a federal employee in 2015. And I want to take this opportunity to stress something that Scott said, is that this is really the first time we're trying to do this. We have recognized over the last couple of years that we are really bad at PR and sort of broader communications with the university. And so we are trying to do better, but give us a little bit of the benefit of the doubt with this one. I think I'm asking because it is the first, and after all of this, we look forward to hearing some of your comments and suggestions for the future. And I'll hand it off to my colleague, Jeff.
Hi, I'm Jeff Stair. I'm the other program manager for ASR, and I've been here since 2019, so good heavens, later this year, that will actually be 4 years. And before that, I was at NASA headquarters and University of Maryland. And I would also like to emphasize Shaima's comment about, we'd like to hear your feedback about this. This is the first one we're doing. We'd really like to learn and see what was useful and what was not, so that we can tailor some of these to what you might like. And with that, I believe, Scott, back to you.
No worries. And I'll hand it over to Sally to introduce herself.
Thank you, Scott. So I'm Sally McFarlane. I am usually the program manager for the atmospheric radiation measurement user facility. And I'm also currently the acting division director for Earth and Environmental Systems Sciences Division.
Thank you, Sally. And Andrew, if you can introduce yourself.
Yep. Hey, Andrew Flatness, Scientific Program Specialist for the EESSD. And my role here today is being the host for the Zoom meeting.
Awesome, thank you. And my name is Scott Collis. I'm on detail 1/4 time to the Office of Science in Biological Environmental Research. My role within the Office of Science is really doing things like this to really help improve access to EESSD and its programs, especially for communities that have typically been underrepresented in our portfolio of research. The other 3/4 of my brain is actually dedicated to Argonne National Laboratory, where I work for a variety of the activities and programs that you're going to hear about today. So with that, I'm going to hand this over to Sally McFarlane, who's going to provide an overview of BER, EESSD, and its constituent activities.
Thank you, Scott. And thanks to all of you for joining us today for the open house. I'd like to start, as Scott said, by giving a very brief introduction to the DOE Office of Science, just recognizing that some folks might not be familiar with it and how ASR fits in that broader context. So the DOE Office of Science is an organization within DOE that supports the basic research to deliver scientific discoveries and major scientific tools to transform our understanding of nature and advance the energy, economic, and national security of the United States. So within Office of Science, as you see in this chart, there are 6 program offices, including the Office of Biological and Environmental Research, or BER, which is where our atmospheric research efforts that we're going to talk about today sit. And BER's mission is to support transformative science and scientific user facilities to achieve a predictive understanding of complex biological, earth, and environmental systems. Within Office of Science, another program office that you may be familiar with is the Office of Advanced Scientific Computing Research, or OSCR. This is the office in DOE which operates the DOE supercomputers that are available to the research community. And then other program offices in the Office of Science do fundamental research in basic energy science, high energy physics, fusion energy, and nuclear physics. So going back to BER, we actually have 2 divisions within BER. One of them focuses on biological system science, and then the other one focuses on earth and environmental system science. And that's the division that all the folks who introduced themselves today sit in. So if you can go to the next slide. So within our earth and environmental system sciences division, we have 3 major research themes. The first is atmospheric research, which we're going to be discussing today. And the second is Earth and environmental systems modeling, which brings together a hierarchy of models from regional scales to global scales. And then our third research area is environmental systems science. And we will be having future open houses discussing the other 2 science themes. Within EESSD, we also support 2 community user facilities. The Atmospheric Radiation Measurement Facility, or ARM, which is the facility that I manage and which we'll talk a little bit more about today. And then also the Environmental Molecular Sciences Laboratory, or EMSL, which supports more of our environmental system science area, but it does also support research in aerosol activities, which might be of interest to this group. And finally, EESSD also has a data management area, which underpins all of our science research themes. So with that brief introduction to BER and EESSD, I will turn it over to Shaima.
All right, thanks. And now I get to talk about ASR, my favorite thing. Let's go to the next slide. So I'll start off with the official goals of ASR. So ASR's official goal is to quantify the interactions among aerosols, clouds, precipitation, and radiation to improve understanding of these key climate relevant, climate critical processes that affect the Earth's radiative balance and hydrologic cycle. And we focus mainly on processes that limit the predictive ability of regional and global models. We achieve this through conducting observational data analysis and or modeling studies that use observations supported by BER, typically from the ARM facility and or PI laboratories, to improve understanding and model representation of climate relevant atmospheric processes. And you'll hear the phrase improve understanding and model representation quite a bit today. Let's go to the next slide. So ASR is organized around 4 priority research areas, which, not coincidentally, are also the name of our 4 working groups within our science team. And so these 4 priority areas are aerosol processes. And here we're focusing on understanding of processes governing the spatial and temporal distribution of atmospheric particles and their chemical, microphysical, and optical properties. Warm boundary layer processes, and this is kind of getting at that understanding and model representation, and phrase that I said you would hear quite a bit. Understanding and model representation of processes controlling the structural and radiative properties of clouds, aerosols, and their interactions with the underlying surface in the lowest few kilometers of the atmosphere. And so when we talk about sort of warm boundary layer processes, there's a lot of boundary layer atmospheric science. We tend to focus on those processes, including thermodynamics, including turbulence, including dynamics, including land atmosphere interactions that are directly relevant to cloud formation, aerosol formation, and those interactions. So there's some areas in boundary layer processes that we don't really support, but it's typically the ones that are related to cloud formation and cloud aerosol interactions. Similarly, with convective processes, we're focused on understanding and model representation of convective cloud processes and properties, including cloud cover, precipitation, life cycle, dynamics, microphysics over a range of spatial scales. And that also includes aerosol cloud interactions within convective clouds. And then we also have a focus on high latitude processes. So again, that improving understanding and model representation of cloud, aerosol, and surface interaction processes, controlling the surface energy budgets in the northern and southern high latitude regions. And we take a pretty broad definition of high latitude when we're talking about the southern hemisphere, because we do really consider anything that involves mixed phase or cold phase clouds in the Southern Ocean as a sort of fitting typically into our high latitude processes topic. All right, next slide. And I think that one thing that I think you're here to get a better understanding of is what makes ASR unique. And this is something that I've thought about a lot, and it is a little bit hard, I think, to, I don't have an answer for that in one bullet point. Unfortunately, I need to go through a bunch of them. But I think the first thing is that ASR supports research that uses observations to improve understanding of atmospheric processes. In general, within ASR, we've moved beyond focusing on, I would say, climatologies of properties, and we're really focused on getting at the processes controlling what's going on in the atmosphere. ASR supports research that makes use of DOE and our division's capabilities, especially ARM, and I'll talk more about ARM shortly. And we also are focusing on aerosol cloud precipitation processes that are relevant to other programs within our office. So the same type of aerosol cloud precipitation and interaction processes that are really key to model improvement and really understanding sources of error in regional and global models, are also the ones that we are focused on supporting the use of observations to improve the understanding of. ASR currently has a major focus on aerosol cloud precipitation interactions. And I think that when we think about research supported within the US research enterprise, ASR has a really big piece of that aerosol cloud precipitation interactions pie. And the other thing is ASR supports research at DOE labs, and many other agencies don't do that, or not to a large extent. ASR also supports research at universities and other research institutions. And I think a major thing is that DOE is a mission agency. And when ASR puts out calls for proposals, we are soliciting research proposals on specific research topics. And we'll talk a little bit more about this process later on. But if you are familiar or most used to putting in proposals to, say, NSF, for example, you probably have a mindset of thinking of your best idea in the moment, and putting together a proposal to do the best science. For putting in a proposal to a mission agency or putting in a proposal to ASR, it is looking at what it is we say we are looking for this particular year, and then figuring out if your best idea is also the sort of thing that we are looking for before developing that proposal. And if it turns out that it's not, that there's not a good overlap that year, that might be the time when you drop us an email and say, hey, I'd love to, I'm not going to be putting in a proposal to your call this year, but I'd love to review for you. And I think another thing is that ASR supported researchers are part of a science team. And I think that we often hear ASR referred to as a community. And we encourage our ASR supported researchers to coordinate their research, develop collaborations, and especially and including with the DOE National Laboratories. And so you'll hear more about those projects very shortly. And so next slide. Another thing that makes ASR unique is its proximity to and relationship with the ARM user facility. So I'm not going to say a lot about ARM. This is the ARM user facility. Our plan is to have another open house later on in this series that's going to go much more into depth about the user facilities, but I don't think we can talk about ASR without also talking about ARM. So ARM is a DOE Office of Science user facility, and its goal is to provide the climate research community with long-term in situ and remote sensing observations of aerosols, clouds, and radiation. Again, very similar to the research areas that ASR focuses on to improve representation of aerosol and cloud impacts on the radiation budget and climate models. ARM has 3 fixed measurement sites, and these are large measurement sites with lots of instruments in Oklahoma, Alaska, and the Azores, so very different climate regimes. In addition, it has 1 mobile facility set aside for mid-range of approximately 5-year deployments, and that mobile facility is in the process of being set up in Bankhead National Forest in northern Alabama right now. Some key characteristics of our fixed sites are 24/7 data collection and near or very rapid access to that data through the ARM data center, and of course all ARM data is freely available, and I'll talk a little bit more about that. In addition to these fixed sites, ARM has 2 mobile facilities that are available for proposal-driven 6-month to 2-year deployments. And so there's ARM puts out a call for proposals. Sometimes there are constraints on that call every year or 2. And this is for the community to put in proposals for larger science questions that can be addressed with a deployment of one of these mobile facilities. So A recent mobile facility deployment took place in the greater Houston metropolitan area, focused on aerosol, deep convective cloud interactions. That was called Tracer. We are wrapping up a mobile facility deployment in the mountains in Colorado, focused on really mountain hydrology issues. This is called SAIL. And we also have a deployment that is right now occurring in La Jolla, California, on the Scripps Institute for Oceanography's research pier, as well as Mount Soledad, that is focused on marine boundary layer clouds and aerosol cloud interactions in these clouds. That's called EPCATE. Future deployment is going to be to Tasmania to look at Southern Ocean clouds and aerosol cloud interactions. That's Cape K, as well as a not yet announced urban deployment. In addition to these measurements, ARM has high performance computing resources for working with large ARM data sets. And ARM has an aerial facility deployment, although I'm not going to say a whole lot about that because ARM has a new airplane, and that airplane is currently undergoing modifications to make it the type of research aircraft that the community needs. Next slide. So I really want to mention that you don't need to be funded by ASR or by DOE or by anyone to take advantage of ARM data. All of the ARM data, and there's 30 years of data from the Oklahoma site. All of that data is freely available to support a diverse number of applications. And so while we think about ARM as this making measurements for aerosol cloud and radiation, research has been used. Research has been done using ARM data from really all aspects of climate science to renewable energy to bird and insect migration. ARM is available as a testbed for evaluating instruments and models. And one thing as a former professor that I can say about ARM is that it is terribly underutilized as a teaching and classroom resource. There are so many ways that ARM data could be incorporated into a standard atmospheric science curriculum. There are 100 different instrument types, and so there's a ton of data available there. ARM observatories host visitors and approximately 50 small field campaigns each year that enable operation of guest instruments, special deployments of ARM instruments, as well as the deployment, the flashy deployment of the ARM mobile facilities. And ARM does training events that are aimed at raising up the next generation of scientists. And I think at this time I hand it off, right? All right. Thank you.
Okay, so within ASR and actually within the Office of Science, we have science focus areas, which are big thrusts run out of national laboratories that are meant to have a long-term 10-year vision. And so these are really key to ASR. We have 3 of them in ASR, and the goal is to achieve scientific research and solutions. These are for long-range problems. These are for things that we recognize are going to take a big, sustained effort over a long period of time. And so the 3 are the Pascal's one, process-level advancements of climate through cloud and aerosol life cycle studies at Brookhaven and Argonne National Laboratories. And then there's I-class, science focus area at PNNL, and that. And then also tying a lot of this stuff together is THREAD at Lawrence Livermore National Laboratory. And in the next couple of slides, we will be talking about exactly what these folks are doing. So these are large projects, it's multi-million dollars a year with deep expertise and knowledge of ASR and ARM. And so they are really deeply tied into taking those ARM observations, bringing them into to work with models and data analysis and get the most out of them that we possibly can. Oftentimes these folks will lead large field campaigns, and So there's a whole bunch of opportunities associated with these SFAs. They love to collaborate. Some of these folks are extraordinary collaborators. So get in touch with some of these folks. Research experiments, responses to future FOAs. There are lots of student research and internship opportunities. SCGSR is the Office of Science Graduate Student Research Program, where you get to, as a grad student, you go for a year, or work for a year, usually part of a summer, with somebody at a national laboratory on a problem related to your thesis. You get to use all of the toys, instruments, and let me tell you, I've seen these. They are amazing at the national laboratories, and work with world-class scientists, just like Dr. Scott Collis on the call with us. What a great way to navigate and network your way to career opportunities for recent graduates. Lots of postdoctoral opportunities as well at the national labs. Next slide, please. Okay, so Pascal's, this is the one that is at Brookhaven National Lab and Argonne National Laboratory as well. So it's a multi-scale approach with emphasis on fundamental process scales, ranging from molecular all the way up to microphysical and global scales. Sort of soup to nuts, what do we need to know about atmospheric processes? And like Shama said, you're going to hear a lot about processes today. So there are five interconnected themes. Aerosol formation and growth and functionality as cloud condensation nuclei. Aerosol radiation interactions, especially biomass burning aerosols, sort of and beyond, a bit extra there. Cloud processes in the atmospheric boundary layer. Convective cloud dynamics and microphysics, and probably the biggest thrust lately has been the highly successful, I would say, tracer campaign, taking a look at aerosol cloud, aerosol and convection interactions in the area of Houston. Phenomenally successful campaign. Glad to have finally gotten it through with all the delays due to COVID, but we're really looking forward to that. We have a big investment in that and a lot of great science coming forward. So Mike Jensen is the leader at Brookhaven National Laboratory, and Rao Kodamarti is at Argonne National Laboratory. Next slide, please. And iClass is probably our longest lasting SFA. So long-term vision is to transform the understanding of climate relevant processes and provide more robust model representations of the climate system through integrating knowledge of cloud and aerosol populations and their interactions with each other and the Earth's surface. So they like to talk about LACI, land, atmosphere, cloud interactions. In atmosphere, you might also just substitute aerosols. So how does the land surface interact with cloud and aerosol processes, and how are these interactions manifested in the climate system? So again, this process level understanding tying into climate relevant understanding and processes. We get down into the nitty-gritty, itty-bitty details of how these systems work. Next, what are the key factors that control transitions in cloud populations? And how are these transitions affected by interactions with all these previously mentioned conditions? Really careful analysis of how some of these systems evolve and develop. And then finally, what are the key processes controlling the evolution, composition, size distribution of aerosols, and the variability of different aerosol and cloud properties? If you are a measurement geek like me, and you take a look at John Schilling's laboratory, you will understand the power of drooling over instruments. These are fantastic facilities, and they have the ability to really break it down into these fundamental bits and pieces of processes and see how they're really working in finite detail. And just down the hall, collaborating with world-class modelers to get this into the models, get this into the mechanisms, so we have a more direct pathway for those. Next slide, please. And speaking of direct pathways, THREAD is our newest SFA, and the goal is, well, there are three big science questions here. Basically, you start with model diagnosis. You diagnose model strengths and weaknesses, transfer that process level understanding based on observations into improvements in the global storm resolving models. So they're able to take our measurements, bring them into to do a bunch of analysis of these big model runs and see how well we're doing with process level understanding, modify some of these, potentially modify some of these parameterizations, and get them straight into model development, because the folks who are building the models, E3SM primarily, and Scream as well, are right down the hall. So they have that direct pipeline. So this really brings all of this together. And then they're also looking at how well Scream can represent interactions between explicitly resolved and parameterized processes, and how well Scream represents the sort of fast interactive physics of local land atmosphere coupling, and the feedbacks from those short time scales to longer time scales. So the goal is process level understanding and diagnosis to integrate recent advancements in DOE observations with the DOE kilometer scale, yes, kilometer scale global model Scream, leading to hopefully a pronounced reduction of uncertainties, and get those measurements and that understanding straight in. Next slide, please. Okay, so we have a variety of calls, as we sort of been hinting at here. We also support a lot of university research and research at other institutions. Just because you're not a university doesn't mean that you're ruled out. Take a look at the funding opportunity announcement, or FOA. Each call has a specific scope determined by programmatic objectives. That way, we've been able to maintain fairly reasonable rates of funding success over the last several years. And so you aren't wasting time with like a 1% chance of success. We tailor our solicitations such that we're going to have selections, and you will have a good chance of being selected if you write a good proposal that's responsive to it. The key is, as Shama mentioned before, take your good ideas, take a look at what we're asking for, and tailor those to what we're asking for. So this is really, mission-driven science. The details of all ASR-funded projects are available on this website. So it's ASR. If you Google ASR on projects, you'll probably get right there. Let's see, with that, I believe we're on to Shama. Next slide, please.
All right, thanks. Let's go to the next one. All right, so this is a brief introduction to ASR. I realize that. One of the things that we really want to make sure that you come away from this open house with is an understanding that we do have a website. It is asr.science.energy.gov. And there's a lot of information on that website, including a newsletter that goes out most months, I would say about 10 times a year. And that newsletter contains stories about ASR science and researchers, highlights from ASR researchers. We actually have a web form for ASR funded researchers to submit what we would call a highlight on recent publications. And also there's a separate highlight process that's very similar for users of ON data. We have links to recent papers that have been come about through support of ASR, news from the Office of Science, information about ASR and other relevant Office of Science funding opportunities. And there's also a listing of employment, mostly at the DOE National Labs, but not only, and upcoming meetings. So as Jeff mentioned, our website does have links to our currently funded projects, as well as past funded projects from the past. And we have been adding a lot of capability there recently, so that the project pages also have links to publications that have come out of those projects. And so that can give you a little bit of idea about who's doing what in the ASR community, if you are maybe looking for someone to collaborate with in the future, or just trying to get a sense of what type of things that we fund. Next slide. So to talk a little bit about our annual funding opportunity announcements. Each funding opportunity announcement has a theme, a set of topics. And as Jeff said, this is designed to meet our programmatic objectives, to take advantage of recent arm deployments, and to really avoid overburdening the community. It's not helpful to all of you to put in proposals to take the month or 2 months that it takes to write a proposal, and then to not have a reasonable likelihood of success. Our funding opportunity announcements must make use of DOE supported observations, products, and/or ARM observatories. These observations have to be integral to the proposed work. Some FOAs have additional observational requirements. They may require that a particular topic may require that you use observations from a particular ARM field campaign. A topic may allow you to or disallow you from using measurements made in your own laboratory to meet the DOE supported observations requirement. We try to write our funding opportunity announcements in such a way that they are clear and that you understand what we are asking for. And so I want to stress that if you read through our funding opportunity announcement and you aren't sure what we are asking for or if something would be relevant, just drop us an email and ask us, and we will help you figure that out. When you write your proposals, they should be written so that they are an atmospheric science generalist can understand them and help refute them. In addition to our research funding opportunity announcements, there are other opportunities such as small business innovation research, SBIR, and small business technology transfer, STTR calls. There's the Office of Science Graduate Student Research call. There's also early career within so the Office of Science puts out an early career call for proposals every year. Typically within our office, we rotate the topic across our office. And so usually we have an atmosphere topic every 3 years. And so of course, for all these early career opportunities, there are, a strict list of requirements and limitations, but keep your eyes open for that. And then I wanted to also point out that we know that it can be hard to keep track of all of these funding opportunity announcements. We do provide information about funding opportunity announcements on the ASR webpage. You can find out about them if you go to the BER funding opportunity announcement page. But honestly, the best way to find out is to sign up for Gov Delivery. And there is a link on the slides, which will be made available to you. And it was also posted in the chat on how to sign up for Gov Delivery from DOE and finding out about our funding opportunity announcements. All right, next slide. So a few things about our FOAs. I really wish that I could tell you that our FOAs are always released on such a date, and that you could plan easily around them every year. Unfortunately, that's not the case. There are a lot of factors that are involved in it. All I can really say is that our ASR FOAs are typically released in the fall, but that's kind of a broad definition of fall. One thing that is key is that pre-applications are required and they have to be submitted in our PAMS web system by the deadline listed in the funding opportunity announcement. The pre-applications are reviewed by program managers for responsiveness to the FOA topic. And so that means that it's really important when you are writing the writing your pre-application to make sure that we can easily tell that it is responsive to the topic. And so that can be focusing on the science questions that are listed for that topic, make clear that you are using data sets that are required for that topic and that they are integral to the proposed research. And then as well, that you are focusing on improved understanding of atmospheric processes, and those processes are listed. Encourage, discourage decisions are sent through PAMs on or before the deadline listed in the FOA. And only PIs who had an encouraged pre-application may submit a full application. While pre-applications can be submitted by the PI and PAMs, full applications are submitted by your institution-sponsored research office through grants.gov by the deadline listed in the FOA. And so that also means that you have to deal with your own institutions, deadlines for getting things through your sponsored research office. And I think at this time, I can hand things back over to Jeff.
Yeah, thanks. Again, Shama was talking about the importance of these pre-applications, and the purpose of those is much like narrowing our focus on very specific topics. We want to make sure that these are responsive to those topics so that you aren't wasting time with a non-responsive proposal or the non-responsive idea. So it's not some urge to keep the guild closed. It's an interest in keeping our community, respecting our community's time. Next slide, please. Okay, ARM data. This is one of the great things about this program is the connection to the ARM user facility. ARM data is free to use. As Shama mentioned before, you could base a whole course on this. You could, and it comes in fairly live and fairly quickly, as quickly as reasonably it can. Some instruments require extensive calibration procedures. So it's there for you to use in fairly real time, especially for our three large fixed sites. And you can propose to do a small field campaign out there. Imagine being able to take your instrument, your pride and joy, your little widget that measures one particular thing. It's great to take it someplace and measure some things, but you really want to have characterization of what's going on in the rest of the atmosphere. This allows you to do that. You have a team of dedicated scientists and engineers and technicians out there. A lot of these folks who are the instrument mentors are people who work with these instruments every day. But I don't mean just this general class of instrument. I mean, oftentimes this exact instrument, so they know its finicky quirks. You have that whole background. You can bring your instrument to the site, you can use it there, and you get this incredible backdrop of information that you otherwise really wouldn't have. So you can use your instrument to the site. You can request some revised instrument sampling strategies of the ARM instruments to within reason. Obviously, we're not going to tear the whole motherboard apart and do something totally different. You can request increased radio sound launches if you need increased profiling of the atmosphere. Small campaigns are reviewed on a rolling basis. I urge you to take a look at the submission process. It's actually really quite simple. They're reviewed, and consider this the start of a conversation with ARM for how you would like to do this. This is not a pass-fail type of submission. This is a talk to us, give us a good idea of what you're going to do, what you'd like to do, and we'll talk to you about what we need to do. As we scale up a bit here, ARM, on the order of annually, issues calls for proposals to deploy the ARM mobile facilities, mentioned before, to regions of specific interest, and to deploy its tethered balloon systems as well. The tethered balloon system is a really interesting thing that's relatively recent, but booming in popularity. And we also accept user proposals or ARM also accepts user proposals for use of high performance computing resources to analyze large volumes of ARM data. So this is not an independent modeling resource, but if you need to do a lot of analysis, this is a great place for that. Here I might ask Sally if you would like to sort of stick in a word or two for the ARM facility.
No, I think that's, we've covered the ARM facility pretty well.
Okay, and we will have an airplane, I'm sure. It's just not right now. So yeah, meetings. Sure, I'm biased, but in this case, I'm right. The ASR ARM Joint User and Principal Investigator meeting is one of the best meetings out there. It's the right size. You have enough people there to have a critical mass, but it's small enough that you can go up and talk to the most important person at that meeting for you. And I'll give you a hint. It's not me. It's not Chima. It's not Sally. The people that you need to connect with, you can have long conversations with, and there will be somebody there in your field of expertise doing some really interesting stuff. There's a congeniality, a collegiality in this meeting. You don't get lost like you do at huge meetings. So a plug for the PI and user facility meeting. We also go to society meetings like AMS and AGU. Look for town halls and sessions, especially organized by ASR scientists. And we oftentimes will have booths and exhibit halls. These are great places to engage with funded PIs and DOE staff. Shama and I will oftentimes be there. It's more or less a place, if you need to grab us, you know that we'll be there at that time. But the reality is, if you need to grab us at one of these meetings, send us an email, set something up ahead of time. We spend a fair bit of our time at these meetings talking to PIs and prospective PIs and researchers writ large. And for me, that's one of the great joys of this job. Next slide, please. Other ways to engage. BER writ large and ASR in particular, we do host small and medium-sized workshops. We may request white papers to inform workshop planning and develop a list of participants to invite. You can virtually attend the BER Advisory Committee, BRAC, and you can volunteer to review proposals on the other EESS for ASR and other EESSD programs. The first time I did this, it was an incredible education in how to write proposals and the things that I had been doing before, which is namely how not to write proposals. Take notes on what you're seeing as you're reviewing these proposals. There's nothing quite like seeing like 15, 20, 30 proposals. You won't be reviewing that many yourself, and to see where the pitfalls are and how to greatly accelerate your own grant writing process. It's impressive. We also, ARM has been doing a great job of webinars and training, including short courses in summer schools. Stay up to date on these and stay tuned for our newsletters from ARM and ASR. Those are great places to see those. And with that, I think I throw to Scott.
That is right. Thank you very much, Jeff. Thank you, Shima, and thank you, Sally, for that overview of BER ESSD and the ASR atmospheric systems research activities. So this is the part of the seminar where you are highly encouraged and welcomed to ask questions. I am actually going to stop sharing my screen so I can see things more clearly. Please use the raise hand function, and I will attempt to call on questioners in the order that the question is asked. I'd encourage folks, if you have a question, please ask it, because it's highly likely several other people have the same question. And as clear and as concise as this presentation was, I'd be surprised if you don't have questions. Are there any questions?
What I was going to say is, while you're thinking about questions, I did really want to stress again, thank you for coming to this open house. And one of the main reasons, motivations for having this is for you to have a chance to have at least a virtual introduction to Jeff and me and Sally, so that hopefully in the future you feel more comfortable reaching out to us if you have any questions. We are here for you. It's our job, and so please reach out. It looks like written questions.
Yes, Yemi.
Hi everybody. Gonna move my screen here. Yeah, I have a question, but I kind of know a little bit about it, but I thought, you could use this opportunity to talk a little bit more about specifically how can scientists at a university like us apply to you to, say, deploy facility in a particular location, maybe for, like you said, a year or something like that? What are the steps?
Yeah, I can answer that. So ARM puts out a solicitation for the mobile facility proposals approximately annually. It depends a little bit on the timelines of the current deployments. So when a mobile facility is actually available. And so ARM announces that in their newsletter and on their website. We also have tried advertising in some other areas like EOS and BAMs. But so that announcement goes out, and then a pre-application is required that kind of indicates the area you're proposing for the mobile facility and the science, the basic science goals of your deployment. And then those will be reviewed by ARM and BER, and then requests for full proposals will go out.
And ARM did a how-to seminar, didn't they? Are they gonna do that again, or is that available?
Yeah, that's a good point, Shaima. There was this past year in December, I think, ARM did a webinar on our field campaign process. And so that's on the ARM website, and I can find the link and put it in the chat for you.
And, sort of informally, one suggestion that I might have, and I'll bring this up because I know you, Yemi, are planning on coming to the ARM ASR meeting, is you might want to talk to PIs of some of the recent campaigns. I am sure that they will have some advice for you too about, kind of that process and the timeline and things like that, and the questions to ask.
Thank you.
Excellent advice. Geeta.
Yes, and thank you to all the DOE folks for the great overview there. So I have a question as a university PI, whether you could speak to the value of collaborating with DOE scientists at DOE labs on these proposals, particularly on the parts of ASR that interact with the modeling components, the SCREAM model and so on. And if it is really I imagine it is really valuable to collaborate with DOE folks on those. And if so, sort of what the best ways of getting connected with those communities are if we have research ideas that we know we would want to propose within those platforms.
Can I take this one, Scott?
Oh no, go ahead. I saw you.
Okay, I just want to say thank you. This was this is a great question, and I think it helps us clear up a couple of things. One thing that is different across the different offices within different sort of activities within our division is whether DOE National Laboratory staff can be funded on our funding opportunity announcements. Typically for the ASR sort of annual FOAs, we don't allow funding to the national laboratories, which also means that, you don't have to have a national laboratory collaborator. However, I think especially on some of the modeling sides and working with something like SCREAM, it can be really valuable to make some connections and potentially have someone as an unfunded collaborator on your proposal. I think that there are a couple of ways that you can do that. One is, especially I think through SCREAM and for ASR, might be reaching out to the Thread SFA and, sort of talking a little bit about what it is that you're interested in doing. I think also if you're really wanting some help in making connections, you are welcome to reach out to us. And we can at least, maybe introduce you to someone or help you, send you a link of kind of who's doing what in the community. We can at least help get this started. But I think the thing that I want to stress is unfunded collaborations, leveraging work that is already going on in the laboratory, totally allowed, can be really helpful. But don't feel that you're required to have someone from the national laboratories on a proposal if it doesn't make sense.
Yeah,
Thanks, that's really helpful.
They are not, the national laboratories are not gatekeepers, but they love to collaborate. So don't be shy. Chances are you can find some common ground. And if you get a hold of somebody and they're not the right fit, chances are they know who is. So consider it the start of a conversation, the start of networking. And we don't always know the exact details of who is feeling completely overloaded and who is just dying for Gita to show up on their doorstep and offer to work on something. And be a little bit flexible. Maybe they're already working on that, but they have this idea that they really need somebody to pursue, and they'd be happy to have somebody work with them on that.
Excellent. I'll hand it over to Navid for their question.
Hey, can you hear me?
Yes.
Yeah, thank you so much for the nice presentation. It's my first time learning about your program, and it's very exciting to see these topics. And I have a couple of questions. One is, I'm really interested to see how we can use the available data for teaching and education. So the question is, I didn't have checked the data, unfortunately, but my question is, are they like fine resolution, coarse resolution? What type of data we have? And then the other question is, do you already have a procedure on how we can use these data sets for teaching, or this is something that we need to take the data and process them?
Sally, are you able to take that question?
Yeah, sorry, I couldn't find my mute button. Yeah, so ARMS data is primarily remote sensing data. So the ARM sites are at fixed locations, and most of the instruments are looking up at the atmosphere. So there's quite a range of data types. So it is it's hard to say what a given resolution is, because it depends very much on the instrument. In regards to using the data for teaching and, student research projects, I know that there are a lot of PIs that have done that. I don't know that we have really good examples of that. And so that might be something that, we should kind of take back and ask for PIs who have done that to, maybe put together some ideas or let us know what they have done with it. But I don't know, Scott, if you know of any.
Yes, now I'm kind of mixing roles here. ARM does have a new workforce development coordination system. I'm going to put a link in the chat to one of our first activities, which was a short course at the AMS annual meeting this year. We also have a new, one of the ways in which we are trying to enable workforce development using ARM data is through the use of cookbooks that actually show some example use of ARM data. So I'm going to put a link in the chat, and that should help on-road you. I would say please reach out to the program managers, then they can link you to the activities that we have within ARM. Just to be very clear here, ARM is a user facility that is actually managed by a series of national labs. So that's why DOE can kind of link you into that process, and ARM can put you in the right direction there.
That would be great. Thanks so much. Yeah, because I was trying to do this this year. I had gained access to a couple of data set, big data set. We had spent almost 6 months to clean them, understand them, and we found that the data set is not complete, or they had different types of format. And honestly, after 6 months, we stopped doing it. So I said, I need to find another data source doing that. Yeah.
So the ARM data is all going to be in that CDF format. So it's in a common format. There are there's everything from the raw instrument data, the calibrated data. It may take a little bit getting up to speed, just understanding kind of what the data levels are. But like, if you don't have your own radiosonde system, ARM has been launching radiosondes around the world for 30 years. And so that data is available. There's radar data, there's microwave radiometer data. There are a lot of different, standard, a lot of different data types. So hopefully it'll be helpful to you.
There's also in situ data. So if you like particles, if you like detailed sort of on the ground analyses, those kinds of, even some trace gas stuff. If you're interested in that sort of thing.
Yeah, my next question is actually related to this one. That my question is, this program, do you address the mesoscale to microscale analysis as well, or you mainly look at the bigger scale analysis?
You know, it's going to depend on the particular question. So we're really focused more on the processes that are occurring.
Okay.
And so, yeah, I think that would be my answer there.
Okay. And is it I heard from some other program directors that when the funding opportunities is announced, they cannot answer questions. So if I have something, can I write a one-page summary of what I have in
No.
mind, send it to you? And
So let me say a little bit about what we can say. We cannot pre-review a pre-application. So pre-application is usually 2 pages long. We can't pre-review that for you.
okay.
But you know, things that we can sort of, you know, you could ask more broadly, you know, sort of whether something is kind of generally in scope. We could potentially ask that, you know, answer that type of question. But that's a little bit it. We can't, it's that kind of legalese difference between saying, but the answer that we can often give is, it would be difficult it's going to take a lot of work to make this idea responsive. Or it's pretty clear to me how this could be made responsive, because it's all going to depend on how you write it. And since we can't pre-review it, we don't get to see the whole thing. But that doesn't mean that it's not useful to ask us questions. I think it is very useful to ask us questions. It's just understanding what we can and can't say.
I mean, you can certainly ask clarifying questions about the FOA, you know, what you mean by a certain topic, or if there's elements that you find unclear in the FOA. Definitely, you know, we can answer those sorts of questions.
Thank you so much.
There are times when we make mistakes. One part of the FOA says one thing, the other part of the FOA says something that's similar, but not quite. So we can help clarify some of those things. And as Shaima said before, you know, get in touch with us. Don't guess. If you have the question and if something doesn't quite make sense, chances are we can clarify that. We can't talk about, is this responsive? But we can clarify.
Sure. Thank you.
Fantastic. And please forgive me if I mispronounce your name, but Ardashir.
Very well, that's correct. You pronounced it perfectly. So good afternoon, everyone. Thank you for taking the time. I'm Ardashir Iftahaj from University of Minnesota. So I just have a very quick question. How essential is the use of DOE data and models in the context of the idea that we put forward? So for example, if I have an idea to use CloudSat, for example, observation that is a NASA satellite to address like global processes that controls the cloud formation, cloud liquid water content, or those things that might be of interest of DOE, but I send the proposal and you guys say, oh, there is no DOE data in it, there is no DOE model. How essentials are this kind of data set that DOE produce for us to use it in the proposal? This is the first. And the second question, what's the review timeline? Because, well, I had an experience that I sent a proposal to DOE, I just sent one proposal and didn't get funded. It's just fine. But it took like more than a year to hear back from DOE. For us as academicians with this success rate, it's very helpful for us to know, for example, in a short time span, that, okay, this proposal is dead, I need to revise it, I need to do what. But when it takes so long, it's just really difficult for us to manage our group. I was just curious to know about the timeline of your program. I appreciate the response. Thank you so much.
Yeah.
DOE data are essential. So it doesn't have to be the end all be all. But we do want you using, usually it'll be ARM data, but we want that to be an integral, it'll be in the FOA, and either we've centered on either an integral part of the analysis, so it has to be critical to the analysis. It can't be some secondary. Oftentimes the most common mistake is people are just using it to validate a model performance. And
Mhm,
that's, you know, then you're really doing, that's really modeling, and maybe the modeling folks will have a call for that. But we don't mind people using ARM data and then using, for example, CloudSat data to put things into context.
Okay,
So it can be used as ancillary data, but the primary data should be the DOE data. And there are other sources as well. There's MSIL that will have stuff that's useful for certain types of data. Now you mentioned timescales for a response. And if it's over a year, it didn't come from ASR.
no, it was not from ASR.
Yeah, so it takes something like, if you're going to be winning, it's like 6 to 8 months or so. If you win, it might.
So, yeah, I will say that we typically make our, and this is just due to workload considerations. We will typically contact folks who we are recommending for support before we contact those who we are not recommending for support. But once, and there are some limitations, there are some pretty strict limitations on what we are allowed to say before DOE makes formal announcements. But I would say in general, we try to get at least an informal decision out to PIs within 9 months.
Thank you so much.
We try to do things sooner than that, but we are only a couple of people doing all of this, and it is a surprising amount of paperwork. But we recognize the issue that you have. And one thing I will say is that if you are in a situation where you have an opportunity to put in a proposal based on something like, you want to turn around a proposal and submit a similar idea to another agency, don't wait for us to tell you yes or no. Drop us an email, let us know the circumstance, and we will tell you what we can. Sometimes we're not telling you anything other than it might be a good idea to go ahead and do that. But we are human. And
Definitely.
sometimes that means that we're slow, but I think it also means that we understand the situations that you're in, and we are trying to help you out as much as we can, even if we can't give you money.
Thank you so much. Appreciate that.
And I'll just quickly add that we will be having open houses for the modeling program and Earth System Science program that will have activities that do not require the use of ARM data in their responses to funding opportunity announcements.
Thank you so much, Scott.
Okay, do we have any other questions? All right, with no takers, I want to reiterate something that Jeff, Sally, and Shima have all said, which is their inboxes are reasonably open, but given the timescales which they mentioned, how busy everyone is, it won't be an instantaneous responses if you wanted to follow up. So thank you all very much for attending and for the excellent round of questions and answers. As I said, this webinar has been recorded. We will be at least making this available to the participants and to DOE, and maybe looking at making it further available, given the excellent information that was provided, and how I particularly think this will be useful to a much broader community. So I also personally want to thank Jeff, Sally, and Shima again, and also of course Andrew for helping put this together. So a virtual round of applause. And again, don't be a stranger, and I look forward to meeting many of you in person in the future.
Thank you.
Thank you.